Hey everyone, and welcome. Today we're diving into a really powerful tool for anyone who designs databases, the Enhanced Entity Relationship Model, or EER. If you've ever found yourself struggling to map out complex, real-world data hierarchies, well, this one's for you.
I mean, think about it. The real world is messy, right? An employee isn't just an employee. They could be a manager, an engineer, a technician, and each one of those roles has its own unique details. So the big question is, how do you capture all that rich hierarchical structure in your database design?
The standard entity relationship model is a fantastic starting point, but it kind of hits a wall when you have entities with all these distinct subgroups. If you try to force these complex structures into a basic ER diagram, you often just end up with a tangled, messy, and really inefficient design. And that is exactly where the EER model comes in. It takes everything we know from the standard model and enhances it, adding a whole new layer of concepts specifically built to handle these real-world hierarchies in a clean, elegant way.
So, how are we going to break this down? First, we'll touch on why we even need to enhance the basic model. Then we'll jump into the absolute core ideas, superclasses and subclasses. After that, we'll check out the two ways you can build these structures, define the rules that hold them together, and then finally, we'll see how it all fits into the big picture. All right, so let's start with that big question. Why enhance the model in the first place? It's really because the real world is just packed with these natural hierarchies, things that have specific subtypes. EER gives us the precise language to represent them accurately and clearly. So, how does EER actually organize all this hierarchical data? Well, it all boils down to two core ideas you're going to see everywhere: superclasses and subclasses. Let's start at the top. A superclass is your big, general umbrella category. Think of it as the parent entity. In the example we'll be using, that's employee. This is where we put all the common stuff that every single employee has, like their name and social security number. And a subclass is just a more specific group within that superclass. So secretary and engineer are both subclasses of employee. And here's the magic part. It's called inheritance. They automatically get all the attributes of an employee, plus they get to have their own unique attributes on top of that.
Okay, now when you see a full diagram like this for the first time, I get it. It can look a little intimidating, but don't worry. Seriously, just think of it as a family tree for your data. You've got the main ancestor, employee, right at the top. And everything branching off below it, those are just more specific types of employees. We're going to break down exactly what all this means piece by piece. And this is that idea of inheritance in action. See, the employee entity at the top has attributes like name and SSN. Well, because secretary is a subclass, it automatically gets all of that stuff, plus it has its own unique attribute, typing speed. Same thing for engineer. It inherits the basics and adds its own specific engineering type. It's just a super efficient way to avoid repeating the same information over and over again.
Okay, so we know what these hierarchies look like, but how do you, as the designer, actually go about creating them? Well, there are two main ways to think about it, and they're basically mirror images of each other: specialization and generalization. And this really shows you the two sides of the same coin. Specialization is what we call the top-down process. It's like you start with a big category and you're zooming in to find the more specific groups inside it. Generalization is the bottom-up reverse. You're looking at a bunch of specific things, you notice what they have in common, and you zoom out to create a general category for them. Let's look at our main diagram again, but this time through the lens of specialization. This is a perfect example of that top-down approach. We started with the big, general superclass, employee, and then we specialized it. We identified the distinct subgroups within that category: secretary, technician, and engineer. Now let's flip it and look at the opposite process, generalization. Imagine you're designing a database for a car dealership. You might start by modeling car and truck as two totally separate entities. But you'd pretty quickly notice they have some things in common, right? Both have a vehicle ID, a license plate no, and a price. So instead of repeating those attributes for every single type of vehicle you sell, you can perform generalization. You pull those common attributes up into a new, more general superclass that you can call vehicle. This makes your whole model cleaner, way more efficient, and honestly, a lot easier to manage down the road.
Okay, so we've got the structure and we know the two ways to build it, but there's another crucial step. We have to define the rules. We need to be specific about how an entity can be a member of these different subclasses, and in the world of EER, we call these rules constraints.
Let's make this really concrete. Looking back at our employee model, is it possible for one person to be classified as both a secretary and an engineer at the same time? The answer is actually hidden in a tiny symbol on the diagram.
And there it is. That small circle with the D inside it, that's the key to everything. That D stands for disjoint, and this one little letter sets a fundamental rule for how this entire group of subclasses has to behave.
So, the disjoint rule is simple. An entity can belong to only one of the subclasses in that group. In our example, an employee is either a secretary, a technician, or an engineer. There can't be more than one. Now, the opposite is an overlapping constraint, which you'd mark with an O. That would allow an entity to be in multiple categories at once. Think of a university student who is also a part-time employee.
And there you have it. Those are really the core concepts that make the EER model so powerful. So let's do a final, super quick recap to see how it all comes together.
So we start with a general superclass. That's our parent, like employee. From that, we define our specific child entities, the subclasses, like secretary. They get all their basic attributes through inheritance. We can create this structure from the top down with specialization or build it from the bottom up with generalization. And then finally, we use constraints like disjoint or overlapping to enforce the membership rules.
At the end of the day, these diagrams just let us model the messy, complex real world with so much more accuracy. So, I'll leave you with this question. Now that you understand the building blocks, what's a complex system you'd want to map out? A university? A hospital? Maybe a library? The EER model gives you the tools to do it with real clarity and precision. Thanks for tuning in.